Here's the problem of the day from yesterday. We need to factor this completely. So the first step in every factoring problem is to look for a common factor. So look at the numbers first, 7, 28, and 35. Well, they have a 7 in common that you can take out. And then look at the variables. They all have x's. And then you need to take out the one with the smallest exponent, so x to the 7th. There's your greatest common factor. So that means in parentheses we'll need x squared so that we get the 7x to the 9th back, and minus 4x to get the middle term back, and then we need minus 5 to get the last term back. And then we can factor that trinomial again. So we have 7x to the 7th. From the first term, we know that we have x of x. We'll have different signs. Consider the factors of negative 5. So we have negative 1 and 5, or 1 and negative 5. When we add, we need to get negative 4. So that would be the second possibility. So that means we need the 1 with the plus and the 5 with the minus. And there it is. Questions on that one?
How do you know when you can factor it
Well, you may not know at first, but you have to try. So if we had set this up, but our combinations with the 1 and the 5 did not work, then we wouldn't be able to go any further. But sometimes all you can do is factor out a common factor. Other questions so far?
Is that from what we did yesterday?
That's the problem of the day from yesterday.
Yeah, mine was definitely not great. I don't even know what the heck I was doing.
Do you have any questions so far on the homework for the factoring? Anything so far? Anything but the equations, as we haven't covered that yet. Okay, then we will continue with solving quadratic equations. Oh, actually before, I'm sorry?
Solving quadratic equations.
Yes, and actually we're going to do 26, 27, and 28 before that. I had asked that everyone do those. We kind of ran short on time yesterday. So we did some examples, and then I asked people to do this. So let's take a look at that. Okay, so number 26. We have p squared minus 9. There is no greatest common factor, but it is that one special case we talked about yesterday, the difference of squares. So we can set up two sets of parentheses. Square root of the first term is?
P.
So we have a p and a p, and then we'll have a sum and a difference. And what's the square root of 9?
3.
So then we'll have a plus 3 and a minus 3, and there it is.
So how do you know if it's a plus or a minus or a minus?
You could have the minus first and then the plus. So the key is when you have the difference of squares, something in this format, you'll always have a sum and a difference in your factoring.
Okay, so if it's addition, then it'll be
If you have a plus in the middle, that's called the sum of squares, and you cannot factor that. Sum of squares is non-factorable, but this is how you would factor the difference of squares. So 27, is there a greatest common factor? Is there something we can take out of both terms? No? Is it the difference of squares? It is. It is a difference because there's a minus, and both 100 and k squared are perfect squares. So we set up the two sets of parentheses. Square root of 100 is 10. So we have a 10 and a 10. Plus and a minus.
you have to put the 10 first.
Yes. The reason being, now the square root of k squared is k. If we FOIL this out again, or use the shortcut rule, we would get a positive 100 and a negative k squared, and that's what we started with. If we switch the order and put the k's first, then our k's will be positive, and the 10 or the 100 would end up to be negative, and that's not what we started with. It does look kind of awkward with the number first. We're used to it the other way around. 28. Do we have a common factor? Well, the numbers are even, so there's at least a 2. But actually, there is a number bigger. Can you find it?
Three.
3 also works, but there's a number bigger. What's 2 times 3? 6. 6 will work, and that's the biggest one. So we take out a 6, what's left? 4, x squared, yep, minus 9. So we have 2 terms left in the parentheses. Is it the difference of perfect squares? Yes, it is, so we can factor again. Square root of the first term is 2x. So we have 2x and 2x, a plus and a minus. And the square root of 9 is? And there it is. Okay, now let's continue with the equations. Well, the equation being factored and equal to 0 is a very good thing. They've actually done some of the work for us already. So from this point, if this is really a true statement, then either x minus 3 has to be 0 or x plus 4 equals 0, because when we multiply, we have to end up with 0. One of them must be 0. So x minus 3 is equal to 0, or x plus 4 is equal to 0. So now we'll have to solve each of these. How do we solve the first one? Add 3. So x is equal to 3. What do we do to the second one? Subtract 4. So x is equal to negative 4. We end up with 2 answers. Any questions on the first one? Okay. So the second one is similar. It's factored and equal to 0. So we need to set each factor equal to 0. 4t plus 1 is equal to 0. Or 3t minus 1 is equal to 0. I'm sorry? Oh, minus 2. Yes, thank you. So what do we have to do to the first one? Subtract 1. So 4t is equal to negative 1 by, we divide by 4. So t is equal to negative 1/4. There's our first answer. What do we do with the other equation? Subtract 2?
Oh, add 2.
Add 2. There you go. So 3t is equal to 2. Next step.
By 3.
So the second answer is t is equal to 2/3. Number 3 is different. The equation does equal 0. That's a good thing. What do you think we're going to have to do next?
We're gonna have to do the problem with the days. I don't know what that's called.
Factoring?
Yeah.
Yes, we have to factor. Is there a greatest common factor?
No.
Nope. So we set up 2 sets of parentheses. And then what?
It's X and then one's are they both subtraction?
Oh, you missed that
Wouldn't
part.
it be an
I'm sorry?
What would be a positive and a negative?
Yes, to figure out the signs, we look at this sign first. Since that's a minus, that tells us that we have different signs down here. If it had been a
That's what I was
plus,
wondering about earlier.
I'm sorry?
That's what I was wondering about earlier when I asked because I didn't really see.
If what's circled up there had been a plus, that would mean that both signs are the same. And then if you look at the other one, it tells you what they are. So if this had been a plus, and this is a minus, then both will be minus. So now we have to consider the factors of negative 6. So there's negative 1 and 6, 1 and negative 6, negative 2 and 3, 2 and negative 3. When we add, which pair will give us a negative 1? We need a negative 1 here in the middle.
Two minus
2 and the negative 3. So that means we must have the 2 with the plus and the 3 with the minus. So what's next?
3. And you set up both equations equal to 0.
Yep, we set each factor to 0. So x plus 2 is equal to 0, or x minus 3 is equal to 0, and we solve each of those. So the first one, we'll have to subtract 2. So you should get x is negative 2. The second one, you need to add 3. So x is equal to 3. Any questions on that one? Okay, so that was a little bit harder than 1 and 2. Now number 4 is just a little bit harder than number 3. Any suggestions for how to start number 4?
You subtract 28 instead of
Very good, yes. We need this to equal 0, so we need to start by subtracting 28. So we have x squared minus 3x minus 28 is equal to 0. And by the way, that's called standard form. So if the equation is not in standard form, you need to put it in standard form. And then what do you think we need to do? Factor. So we'll have an x and an x. What about the signs?
plus and minus.
A plus and a minus. Factors of negative 28. Whoops, sorry, that one's down the way you can't see it. Okay. So, we multiply any of those pairs, we're going to get negative 28. When we add, we need to have negative 3. So which pair works? 4 and negative 7. So the 4 must be with the plus, and the 7 must be with the minus. Next step?
Set each on it equal to 0.
So x plus 4 is equal to 0, or x minus 7 is equal to 0. So what do you need to do to the first one? I'm running out of room. Subtract 4. So x is equal to negative 4. And what do you need to do to the second one? Add 7. So x is equal to 7. Any questions on that one? Okay. Now you work on 5 through 9, please. So that gives us x is equal to negative 12. Second equation, we need to add 11. And that gives you x is equal to 11. Questions on 5? So number 6 is in standard form because you have everything on one side of the equal signs equal to 0. So next step would be to factor. The first step in any factoring problem is to factor out a common factor, and we do have a common factor in this case. We could take out an x. So that leaves x plus 18. And if that's true, the first factor is equal to 0, or the second factor is equal to 0. So the first one is already solved, x is equal to 0. The second one, we need to subtract 18. So x is equal to negative 18. Any questions on number 6? Number 7 is also in standard form. So now we need to factor it. There is no common factor on this one. So we set up 2 sets of parentheses. We have an x and an x. What about the signs? They're both going to be negative. And then we need the factors of 15. So negative 1 and negative 15, negative 3 and negative 5. So we multiply any of those, we get a positive 15. When we add, we need to get negative 8. Which pair works? Negative 3 and the negative 5. Since the signs are the same, it really doesn't matter if we have the 3 first or the 5 first. So if that's a true statement, then the first factor is equal to 0, or second factor is equal to 0. So first equation, we need to add 3. So you should have x equals 3 for the first answer. And then second one, you need to add 5. So you should have x equals 5 for the second answer. Any questions on 7? Number 8. This one is also in standard form. Is there a greatest common factor? No. Since we have 2 terms, this is the difference of squares. Yes, it is. So we set up 2 sets of parentheses. Square root of the first term is? 2x. So we have 2x and 2x. We'll have a sum and we'll have a difference. Square root of 9 is? Now if that's true, first factor is equal to 0, or second factor is equal to 0. So what do we do to solve the first one here, Alexis?
Subtract. You subtract 3 from 0.
Subtract 3. So 2x is negative 3. How do you finish it, Cody?
multiply? Would you multiply? Or would you-
Multiply?
Yeah, would you?
Well, it's actually multiplication right now. 2x means 2 times x. So how do you get rid of that 2? Go ahead.
Divide?
Yes, there you go. You need to divide by 2. So x is equal to negative 3/2. Second one. Nicole?
Subtract 3 from 0. Or add 3 from
Add 3. So 2x is equal to 3. Alexis?
And you divide the 2 by the 3 or whatever.
Divide 2 by 3.
Or, well, you divide it like by 2.
There you go. We divide both sides by 2. So the second answer, x is equal to 3/2. Questions on 8? Number 9. This one is not in standard form. So how do we start this one? We need to add 10. So now we will have 2y squared plus 12y plus 10 is equal to 0. Once it's in standard form, then you can factor. Do we have a greatest common factor?
Oh, yeah.
What's our common factor? 2. We take out a 2, what's left?
6y.
We'll have y,
Y plus.
Squared.
y squared, yep,
6. Or plus 6.
plus 6,
Y.
y,
Plus 5.
plus 5 equals 0. Okay, so let's see if we can factor that again. We have the 2 out in front, 2 sets of parentheses. We'll have a y and a y. What about the signs?
Addition.
Both are plus. Well, the only factors are 5 are 1 and 5. If we add those, do we get 6? So that works. Now that 2 all by itself out in front is never going to equal 0, so we can ignore the 2 at this point. If it was a 2x, we would not be able to ignore it. Then we'd have to set 2x equal to 0. Does that make sense?
So if it's just a number, you ignore it.
Yeah, if it's just a number, you can ignore it, because that number is never going to equal 0. But if there was an x there, 2x could equal 0. Or 2y in this case. So let's set the second factor equal to 0, or that third factor equal to 0. So first one, what do we do?
Subtract 1.
Subtract 1. So y is equal to negative 1. Second one,
Subtract 5.
subtract 5. So y is equal to negative 5. Questions? Let's try some applications. Number 1. The triangular mainsail on Stacy's lightning-styled sailboat has an area of 125 square feet. The height of the sail is 15 feet more than the base. Find the height and the base of the sail. So we're dealing with area of a triangle. Anybody remember the formula? Area of a triangle.
It's base times
Height.
You're close.
half base times.
There you go. 1/2 times the base times the height. So they told us the area, that's 125, so we can plug that in for the A. Equals 1/2 of something. Then it says the height of the sail is 15 more than the base. So the height is, and how do you write 15 more than the base? 15 what?
Times B.
Not times B.
Plus.
Plus. It's more than, it's not times. Okay. So B plus 15, or you could have 15 plus B. Either way is fine. So the B, we don't know what B is. H is B plus 15. Do you have any questions so far? Now, what do you think we should do?
Did you distribute the B?
Okay, we can distribute, not necessarily just the B, but we can distribute 1/2 B. If we distributed just the B, we'd still have parentheses there. So we have 125 is equal to 1/2 B times B would be 1/2
B squared.
B squared. When you distribute over to the 15, well, let's write it as a fraction. 15 over 2B. Do you have any questions of where that's coming from? Okay. Well, that looks pretty nasty. Any suggestions for what to do next? The fractions are making this equation much harder, aren't they? As long as we have an equal sign, we can clear out the fractions. What's the common denominator? 2. So if we multiply everything by 2, the fractions will disappear. So 2 times 125 is 250. What happens when you take 2 and you multiply by 1/2?
Yep.
You get 1. So that's really just B squared. 1B squared or B squared. Now what happens when you distribute that 2 over to the 15 halves?
15.
You get 15. The 2's cancel. So we have plus 15B. That looks much better. Now what?
Can you subtract 250?
We need to, yes, we need to subtract 250, make this equal 0. So B squared plus 15B, subtract the 250, is equal to 0. Now it's in standard form. What's the next step? Factor. There is no common factor. We'll have a B and a B. What about the signs?
Plus and minus.
Plus and a minus. Now you need to find the factors of negative 250 so that when you add, you end up with a positive 15. Let's see if you can find some factors of negative 250. If you can find the right combination. Find it, Nicole? Okay, positive 25 and a negative 10. If you multiply those, you would get negative 250. Adding would give you the positive 15. Okay, so we had it in standard form, we factored, and now what?
We set them both equal to 0.
Set them both equal to 0. B plus 25 is equal to 0. B minus 10 is equal to 0. So first one, need to subtract 25. So B is negative 25. Second one, add 10. B is equal to 10. So we have two answers for the base of the sail. But we do have a problem. Does anybody see the problem? The negative. If you're looking for the length of something, it can't be a negative number. So that one actually does not work. And do we have a label for the base?
Feet.
Feet, yep. So the base is 10 feet. Now we still need to find the height. How do we find the height? We add 15. We use this equation that we had earlier. So h is equal to 10 plus 15, which is 25 feet. Any questions anywhere in number 1? Let's do number 2. A rectangular table in Arlo's House of Tunes is 6 times as long as it is wide. The area of the table is 24 square feet. Find the length and width of the table. So this time we have a rectangle. How do you find the area of a rectangle?
Just base times height.
Base times height or length times width. You could say it either way, doesn't really matter. So they told us the area, that's 24. And they also said the table is 6 times as long as it is wide. So it's longer than it is wide, correct? So let's let W be the width. What should we have then for L? 6W. If it's 6 times larger, we need to multiply by 6. So L is 6W, W is W. There's our equation. So what do we do with that?
Multiply 6W by W.
You can multiply 6W by W, so 24 is equal to 6
W squared.
W squared. Now what would you like to do?
Just kidding, divide.
I'm sorry?
Divide.
By?
6.
Okay, you can do that. (24) divided by 6 is 4. Is equal to W squared. Now what?
Take the square root of 4.
You could take the square root of both sides, or you could subtract the 4 and put it in standard form. So you could do it either way. You guys want to take the square root of both sides?
Okay, whatever is easier.
Doesn't really matter. It's about as broad as it is long. So if you take the square root of both sides, W is equal to, and now because we're putting the square root in, we should consider both the positive and negative possibilities. So we really get plus or minus 2. But like number 1, the negative answer doesn't make sense in this case. We can't have a negative width. So the width would be 2 feet. And the length would be 6 times that, or 12 feet. Questions on 2? Okay, now you work on 3, 4, and 5, please. Number 3, the length of a rectangular garden is 4 meters greater than the width. The area of the garden is 96 square meters. Find the length and the width. So the first sentence says length is 4 meters greater than the width. And area of a rectangle, we said before, was length times width. So substitute in what we know. The area is 96. The length is W plus 4. And W for W. Did you distribute the W at this point? 96 is equal to w squared plus 4w. Did you subtract 96?
No.
It would be good to subtract 96 because that puts the equation in standard form. That would give you w squared plus 4w minus 96 is equal to 0. So once it's in standard form, then you can factor it. There is no common factor. We have a w and a w. What about the signs? Plus and minus. So we need to look at the factors of negative 96 so that when we add them together you get 4. Should be a positive 12 and a negative 8. Multiplying you get negative 96, adding you get the positive 4. So once it's factored, then set each factor equal to 0. So first part, we need to subtract 12. So the width is negative 12, which doesn't make any sense. Width can't be negative. The other one, add 8. So the width is 8, and the label would be meters. The length is, the length is 8 plus 4, the width plus 4, so that would be 12 meters. Any questions on 3? Number 4. The screen of the TI-84 Plus calculator is nearly rectangular. The length of the rectangle is 2 centimeters more than the width. If the area of the rectangle is 24 square centimeters, find the length and the width. So the length of the rectangle is 2 centimeters more than the width. So W plus 2. Formula is the same as it was for number 3. Area is length times width. They told us the area is 24. Length is W plus 2. And the width is W. So this one actually is very, very similar to 3. Next step, distribute the W. 24 is equal to W squared plus 2W. Next step, Cody? Subtract 24. So W squared plus 2W minus 24 is equal to 0. Next step, Alexis?
I'm like way lost.
After it's in standard form, where it's equal to 0, what's next?
Redo W.
Go back to number 3. Go back to number 3. Top of the second column, W squared plus 4W minus 96 equals 0. That's in standard form. What did we do next?
Wasn't it the W plus 12?
What do you call that? That F word?
Factoring?
Factoring. Yep. So next step is to factor. Don't have a common factor. We have a W and a W. What about the signs? One's positive and one is negative. So now you need to think about the factors of negative 24 so that when you add, you get a plus 2. 12 and 2, if you subtract them, you'd have 10.
Oh, okay.
We need to have 2. Difference of 2, so the numbers have to be close together. 6 and 4, there you go. Now we just have to figure out which one goes where. We want to end up with a positive 2, so which one has to be positive? 6 or 4?
Positive has to be 6, right?
Right, yep. So if you multiply those numbers, 6 and negative 4, you would get negative 24. But if you add them, you would get a positive 2. What's the next step after factoring?
Subtract 6.
Well, we set them each to 0 first, and then we would subtract 6. So w plus 6 is equal to 0, or w minus 4 is equal to 0. Subtract 6 gives us a width of negative 6, which does not make sense. The other one, add 4. So the width is 4 centimeters. The length is the width plus 2, or 6 centimeters. Questions anywhere, number 4? Number 5. The height of a triangle is 3 centimeters less than the length of the base. The area of the triangle is 35 square centimeters. Find the height and the length of the base. I think that's supposed to be of the triangle. Find the height and the base of the triangle. So the height is 3 centimeters less than the length of the base. So that should be b minus 3. So the height is b minus 3. Okay with that part? Area of a triangle is...
35.
Yes, it's 35.
Oh,
The
gotcha.
formula is 1/2 base times the height. So we can put the 35 in for A, 1/2 B, and then H is B minus 3. So like the previous example with the triangle, we need to distribute the 1/2 B. So 35 equals 1/2 B squared. Minus 3/2 B. Okay, what would you like to do next? We multiply everything by 2, we'll get rid of those fractions. $35 times 2? And what happens on the other side?
B squared minus 6. No, 3.
3b, yep, the 2's cancel. What's next?
Subtract 7.
Subtract 70 to put it in standard form. B squared minus 3b minus 70 is 0. Next step, Alexis?
Yes, factor.
Yep, we're going to factor. So we have no common factor, so we set up 2 sets of parentheses. We have a b and a b. What about the signs?
One's plus, one's negative.
One's plus, one's negative.
Will it always be that way or no?
The reason it's plus or negative is because the second sign here is negative. That tells you that you have different signs in your factoring. If it had been a plus, then you look at the others. That would mean that it's the same sign, and you look at the other sign, and it tells you what they are.
Okay.
Okay, so factors of negative 70. When we add, we need to get negative 3.
and 7.
10 and 7, good. Now, we just have to figure out which is the plus and which is the minus.
It can't be that way. It has to be subtracting B first, doesn't it? Or, yeah. Because if, okay,
Wh-
so it's gonna be the 7's with the negative and the 10's with the positive.
7 with the negative and 10 with the positive. So let's double check. If we multiply those, we do get negative 70. Now, if you have 10 and negative 7 and you add, do you get negative 3?
Yeah. No. You get
No,
3.
you get a positive 3. So we need to switch the signs. Or switch the numbers. Let's switch the numbers. So the 10 needs to be negative and the 7 positive, so that when you add, you get negative 3. Next up,
Subtract 7.
okay, so b plus 7 is equal to 0, or b minus 10 is equal to 0, so we subtract 7. Base is equal to negative 7, which doesn't make any sense. Now, don't always think that you need to cross off the negative answer. It depends on the situation. Since we're specifically dealing with lengths in all the cases we looked at today, a negative number doesn't make sense. But depending on the situation, a negative number might make sense. So the second part, we add 10. B is equal to 10 centimeters. The height is 10 minus 3, which is 7 centimeters. Questions anywhere, number 5? Okay, we'll do just a little bit with section 10. Go to page 467 in the book, please. Page 467. Read through that page, and if you refer back to number 2 in the previous page, it says to highlight 2 statistics that were most surprising to you. So when you start reading the statistics, you want to pick out 2 that were most surprising to you, and then also do number 4. We're about out of time. What did you find most surprising? Alexis, can you name one thing you found surprising? Number 7? Okay, 300,000 users helped translate Facebook into 70 languages. Wow. Nicole, what did you find surprising?
Number 3.
Number 3? Each Facebook user spends an average 15 hours and 33 minutes a month on the site. Do you guys spend that much time, do you think, on Facebook? What's that?
I probably spend more.
You spend more?
I just look at everything.
What do you think, Alexis? More or less the same? About the same? Cody?
You're more.
Probably more.
A lot more?
Probably.
Okay, Cody, what did you find surprising?
Probably
11? Users on the YouTube spend a total of 2.9 billion hours per month. I'm not on YouTube very much. That is how when I upload videos though, that's how I do that. I upload to YouTube first and then get the code to put it into the course. That's about the only time I'm on YouTube. Number 4, pick one of the statistics you listed and try to make sense of it. Find a different way to describe the information to get a better sense of the size of the figure. For example, Google Plus had 25 million users in September 2011. That's twice the size of the population of Illinois. So this is probably kind of hard to do without actually looking up some things. So maybe you could do that for next time. Okay, so finish number 4 next time, and then we'll continue. There's a crazy graph on page 468 we're going to look at next time. Have a good day.